Number 2, which says in a copper, number 2 is now saying in a copper wire that has a diameter, so D. Okay, don't ever read. Number 2, don't ever read D, diameter. Okay, you can actually skip everything. Diameter D is 1.63 millimeters. And then we have drift velocity, so VD is going to be equal to 7.08 times 10 to the negative 4 meters per second, okay? Times 10 to the negative 4 meters per second. Then what else are we going to have? Then what are they saying? Blah, 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 blah. If we assume whatever, what are the current in the wire? So first, part A, you know that part A is looking for I. They're saying, what is the current in the wire? So we can actually just put all this and say, let's put it as for part A. Part A is then looking for the current in the wire, okay? Current in the wire, and it's saying, what is it? So what am I going to do now? I'm going to see this that I have D. D is the diameter, and I should change it to 1.63 times 10 to the negative 3 meters, because that's what milli means. You can't keep it as millimeters. That's not an SI unit. So watch out for that. Now, if I have diameter, what do I use D to get? Area. So I can just go ahead and find area to say area is equal to pi D over 2 all squared. That's the only thing you use diameter for. So it's going to be pi 1.63 times 10 to the negative 3 meters divided by 2 all squared. What am I going to get now for my area? You can punch in the calculator, right? Exactly this way. Exactly the way you see it here. Make sure you're good at that. Pi, open bracket, 1.63 exp negative 3 divided by 2, close bracket, squared is equal to, what are you going to get? You must get 2.09 times 10 to the negative 6, okay? And what is this going to be? Square meters. This is going to be the solution that you should get first. Remember, if you get 0.000000029, just move the comma until you are left with one value before it. And if it was a 0.000, then obviously the power will be negative. Just count how many times you've moved the comma. If you've moved it 6 times, then obviously the power is negative, so it'll be times 10 to the negative 6. This is going to give us our area. So if we rewrite, we now know that we have area, which is 2.09 times 10 to the negative 6 square meters. Then we have the drift velocity, which we've been given as 7.08 times 10 to the negative 4 meters per second. And they've asked us for, what did they ask for? Current. Okay, so they've asked us for current, and they said, what is it? Now, we know that for current, we have those 3 formulas. We just go up there, and we are going to see them. Is delta Q over delta T? No, this one is not going to work. VE over 2 pi R? No, it's not going to work. NQ VDA? Of course, it's going to be the one. So we're going to say, okay, we're going to have to use the formula current is equal to NQ, then drift velocity, then A. Now, they said we are dealing with what? You can see, let me go back to the question here. They said a copper wire, blah, blah, blah. One free electron. So we are dealing with the electron. So this Q is the charge of an electron. So you can say Q is equal to E, which is equal to negative 1.6 times 10 to the negative 19 coulombs, which is this one we have here. Okay? Then what is the only thing which is missing now? Is going to be the N. Okay? N is going to be the only thing which we are missing, which we are going to have to get now. Now, remember, we should be able to get N. So before we apply this formula, now we're going to get N, which is going to be, N is going to be, you would have put the formula with a pen. So I is equal to NQ. That's the one I'm going to use, NQ VDA. But you can see that we don't have N. So let's find it first. So it's going to be N. Remember, we said what N is going to be the Avogadro's number times E, okay? Then divided by molar mass. So this is going to be equal to Avogadro's number. What is it? What is the Avogadro's number? We can say it is 6.023, okay, times 10 to the power 23 atoms, right? Then what are we going to multiply by? I should fix this here. It's a density, not for the charge of an electron. So it's like a P. It's like a it's like a rho. Density is actually a rho, but here they are putting it with this other thing like this, okay, so that you don't confuse it with resistivity. But anyway, this is going to be the density of copper, which you should know just from your head, off your head, which is going to be 8.96 times 10 to the power of 3, okay? That is going to be your density. It's kg per cubic meter. 8.96 times 10 to the power of 3. Sorry for that, okay? Sorry for that weirdness. So this is going to be density, and divided by M, which is your molarity, okay? M is going to be the molar of the molar mass of your device, okay? And this one, you pick it from your periodic table. I don't know. They haven't given it as to us here on your constants. Probably they would if you have the periodic table at the bottom. So if you check on your periodic table to say, what is the mass of copper? you're going to see that it is 63.5. Remember that the mass is the number at the bottom, right? You see that it is 63.5, but it will be grams per mole. We want it in kg, so you divide that by 1,000, okay? Which instead of 63.5, if you divide 63.5 by 1,000, you get 0.0635. And this is now kg per mole instead of grams per mole, okay? There is going to be our thing, and we can find the number density, okay? And if you punch this in the calculator, 6.02 exponent 23 times exponent 96 exp3, okay, exp3, you get an answer, then you say divided by 0.0635. What are you going to get? You must get it as 8.49 times 10 to the 28. And this is your number density. It's going to be electrons per cubic meter. Okay, it's going to be electrons per cubic meter. This is what you'll be having. Now, what am I going to have? Once I now have this, I can now come below that and say I is equal to NQ VD times A, which is going to be N 8.49 times 10 to the 28. This is electrons per cubic meter. It's going to multiply Q, and what is Q? It's E, is the charge on one electron, okay? Which is going to be, the charge on one electron is, so it's say times negative 1.6 times 10 to the negative 19 coulombs. Then we say times, now we multiply VD, which is the drift velocity, and we have it 7.08 times 10 to the negative 04. So times 10 to the negative 4. So it's going to be times 7.08 times 10 to the negative 4 meters per second. Then we multiply by area, 7.08 times 10 to the negative 4. Then area, 2.09 times 10 to the negative 6. Okay, so it's going to be multiplying 2.09 times 10 to the negative 6 cubic meters. Can you see that? And what are we going to get? When we multiply all this, we're going to get our current. And our current is going to be, remember, put it. So 8.49 exp 28 times negative 1.6 exp negative 19 times 7.08 exp negative 4 times 2.09 exp negative 6. What are you going to get here? Okay, what is the final solution there? You must get 2.02, and this is going to be amps. Here's your final solution. This is going to be your current, 2.02 amps. And you are done. Once you put it this way, you'd be done. So this is going to be our part A, and we are done. Now, we can go to part B and C and whatever in the next video. Goodbye for now. But the idea is there's no thinking. Just write the things down. Write the things that you have been given down. Here we wrote our I, we wrote our VD, we wrote our A. The moment we saw diameter, we knew we had to find area. So we found area, and instead of writing D, because diameter is not useful to us at all. So instead of putting diameter, now we put the word area. That's the one we care about. We don't care about diameter. We've just been given diameter to find the area. So now I can have this, and then I can see, oh, I is missing. And we saw that the only one which works is this formula. But before you just put it, you put it down with a pencil, then you see if there's any term which you don't have. Because if you're looking for I, then you must have all four of them. We saw Q, V, F, VD, we have A, we have, but we don't have N, so we have to find N first. Then we can put our I as this, and it is superb, okay? And this is going to be 2.02 amps, all right?